Chapter 14, Solutions. If you get stranded in the ocean on a little boat and you have nothing to drink, you find yourself surrounded by water, but you can't drink the water, right? You shouldn't drink seawater, not only because it tastes horrible, because it's extremely salty, but it'll actually cause you to become more dehydrated than if you don't drink anything. And so in this chapter, we're going to explain how that happens. So we call seawater a thirsty solution because it draws water to itself. We've talked about solutions before. Solutions are homogeneous mixtures of two or more substances. You have the solvent, and you can have one or more solutes. So in seawater, water is the solvent, and sodium chloride is the main solute. Nature has a tendency towards spontaneous mixing. If we imagine an aquarium with a barrier in the middle, and we have fresh water on one side and salty water on the other side, and we pull this barrier out, and you pull it out very, very carefully so it doesn't, swish things around or anything. Is the salt water going to stay on one side? No, it won't. It might take a while, but eventually it'll become uniform, right? And all the water will become salty, not as salty as this, but also not pure like this. So that is spontaneous mixing, and that will happen unless there's something energy-wise that's really preventing that from happening. So if you drink seawater, so here's a looking at your intestines. So here's the seawater coming through your intestinal tract, and this is a bit like that aquarium where we have salty water on this side. This side also has some salt in it, but much less salt. And so there's a tendency of nature to want to mix these together. This membrane that separates the inside of you from your intestines is permeable to many things, including water. And so water can go through this membrane, and it will. You could think of nature as trying to make the concentration uniform, to make everything mixed up